we'll move on to our next speaker. We are honored to have Dr. Roshni Udyavar, who is a practicing architect and academician whose core ability is energy efficient and environmental design of building. Roshni has a Ph.D. in resource management and is a qualified master trainer and empaneled expert on the Energy Conservation Building Code of India, awarded by the Bureau of Energy Efficiency since February 2015. Today, Ms. Roshni will speak on emerging trends in low-carbon building design. So let's welcome Ms. Roshni.
Thank you, Achal, and thank you, ACE Update, for inviting me. So, as mentioned, my topic is emerging trends in low-carbon building design. We all know that, today our buildings, conventional buildings, are carbon intensive, and going forward, we need to have buildings which are less emitting in terms of carbon. This figure itself shows you that something like almost 50% of global carbon dioxide emissions is from 2019 is from buildings, whether it is building operations, which is 28%, then the materials and the manufacturing of the materials. So all of this contribute towards, carbon emissions, and therefore we're talking about low carbon, which should be the trend. So decarbonization was mentioned before. So that is what we are looking at, and that is what I'll be talking about. If we divide the phases of the buildings, then we have the embodied aspect of the carbon, which is in the manufacturing of materials, the construction itself, and so on. And then we have the operational life of the building, which is depending upon the life of the building. It can be quite a bigger chunk of the whole total carbon of the building. And then we have the last phase, which is the demolition or the deconstruction phase. So these are the basic three areas of the different phases in which carbon is emitted, and which causes, as many of the speakers before have pointed to, climate change and other issues. So what I'm going to do is, today I thought that I'll present 10 emerging trends in low carbon building design in about very short while, about 10 ideas. Some of these ideas may be already known to many of you, and some of these ideas may be new, but definitely they have a potential in terms of the future of buildings and cities. So the first one is small is beautiful. Make a small footprint. The idea is that, for example, a typical house in America would be maybe, 2,500 square feet. In India, it may be 500 square feet. But now there is a trend, even in many European countries, to go small, make your houses smaller, make your footprint smaller. If it's an office space, make it a smaller space, and so on. So reducing your footprint definitely helps in reducing the carbon. So this is one idea. And I think there is a trend, like if you see this is a picture from one of the US cities where they came up with this idea of moving vehicle, which could be parked anywhere, something like that. Of course, the most important thing is how many people, the per capita footprint of the building. So, is it a 10-story building used by 5 people, or is it like, or there are even Havelis that we had in Rajasthan, or that had, numerous rooms, but that were really occupied by people. So it's not about the size per se, it's about the per capita footprint in terms of your carbon emissions. So the future would be something that has a smaller footprint, so per person reduce it. The next idea I thought was 3D printing. Now, this idea has taken up really quite quickly in the last 5 years. I myself was part of a workshop in Oroville where we actually built houses in 3D using mud and, having double walls and so on. So the idea is that this kind of construction, first of all, apart from being fast and maybe the most efficient, it also has things like use of various kinds of waste, plastics, fillers, and things like that. So it's an amazing thing. And I believe that as we go in the future, this can have a lot of repercussions. We can have entire communities, modular, that can be built in this manner. So 3D printing is another new idea that comes to my mind. low carbon materials. So, there was a question in the beginning about materials and cement and all of that. So today you will find that the cement companies themselves, for example, they're trying to look at how they can become low carbon. For example, aggregates, which are, quarried and removed from the earth, how the impact of that can be reduced. So what alternatives can we have? Can we have other types of aggregates? Can we have recycled demolition waste? So, or some kind of waste like fly ash and blast furnace. So I believe that while individually also each and every company that is producing building materials is looking at how to reduce their carbon footprint in terms of the entire value chain, in terms of the embodied energy of each and every raw material that goes into it. And also there are new materials that, of course, are coming up, which are entirely green. But there is a great potential in looking at existing materials like, manufactured sand, for example, is now when there was an illegal action to reduce the reverse sand in construction. So then people came up with solutions. So these are the kind of things that we can look at in the future. High performance buildings, something that Kishan just talked about. Yes, we can have automated AI based, and of course, even the high performance building can also mean something that is highly efficient and that is utilizing very little from outside. It's almost similar to a net zero building. So, everything is on the site, within the site. The idea is that this building has a lower carbon footprint because of the fact that all the resources are within reach, within the, a particular space boundary of the building itself. So we can look at more and more high performance buildings, which will have, low carbon, which will be low carbon. Another idea is energy geostructures, which is, whose use of geothermal energy, which can be both deep geothermal as well as shallow geothermal energy. So this is a concept which is like using these structural aspects of the building into the geothermal. So they are used not just for structural stability, but also for moving the either heating or cooling system, whether it is tapped from deep underground or shallow, depending upon the space and then the requirement of the building. Like in most of the places where it is already done, it would be for heating of buildings, where, in Europe and America, most of it is what they're using is gas. So it's a kind of a new alternative that can be thought of. Phase change materials, or, what is also called as thermal energy storage systems. These can be for, this can help in changing the performance of the building envelope. We had worked on some of these projects on building envelope materials. And at that time, we explored the possibility of these kind of materials, especially which are used in cold chain and refrigeration systems. But, the idea is that something like what Richard Rogers probably projected many years ago about how a building will change according to its surroundings, based on if there's too much radiation, the building material will modulate itself and, change its properties and so on. So this is another very new area, and there are a lot of nano materials that are being used and tried in terms of how buildings can be looked at in the future. And this is another thing that can change the way buildings are built and, reduce their footprint. High density modular. And this is something I thought because, if you look at, we are all talking about urbanization. A lot of cities are coming up, and that's probably the way in which things are going all over the world. So if urbanization is going to be the trend, then how do we build very fast for everyone with very high quality of living spaces? This, of course, is a very well-known project by Moshe Sapti. And there are also very good examples by architect Charles Kovia in Navi Mumbai of, high density housing, which is having all the good qualities, as well as which could be modular. So this is another thing that can be a trend in low carbon. Wind turbines have been, have been known for a very long time as a source of renewable energy. However, in terms of their actual output, they've not given the performance. Like we've seen these huge wind turbines in the countryside across India, but uh, often we see they're not working or something like that. So in terms of their performance, I don't think that they've given the kind of output that we desire. But in a newer trend is to use wind turbines on the top of buildings or as part of buildings, using the local funnel of wind that is available or something like that, and to generate energy. One of the very good examples is the Bahrain World Trade Center, which uses these horizontal axis wind turbines, which generate almost 15% of the building's energy. So another new trend that can be utilized in addition to, of course, solar PV. So the last two things are these bio-based building materials, which can be, hemp and or other products. In our project with DST that we did some years ago, we used rice straws and various other materials similar to this in the construction of newer materials. The last one is energy from algae. We started with biomass. We all were using biomass before the fossil fuels came into being. So this is another new area. So lastly, I will end with this slide. This was a research project we had done a year back in a village called Pangana in Himachal Pradesh, where you can see that they have this is a cross section of a wall, which is a wall made out of stone and deodar wood, and it is coated with mud. What we found is that, the internal and external temperature, the external temperature of, the cement wall, which was built right next to it, went up to 62, whereas the wall surface of the traditional house was something like 26 degrees. The temperature never went up. And the difference in temperature between inside and outside was also remarkable. In terms of the traditional, it was just 3 degrees centigrade, whereas in the new construction, it was almost 15 degrees centigrade. So while we're talking about newer trends, I think it is also important to look back at our own history and our own tradition, as has been already spoken about.
Thank you, Ms. Roshni, for sharing the exciting insight on emerging trends in low carbon building design. For viewers who have joined us today, we would like your feedback and encourage you to stay connected with us via our social media handles. AC Update is available on Facebook, Twitter, and Instagram. You can also download our app from Google Play and the App Store. We also request our viewers to stay tuned for future interactions. With that, today's interaction has now come to a close. Thank you and goodbye.